Hello physicists! In last video we started talking about vector addition, specifically the geometric interpretation of the vector sum. So the sum of two vectors and how we can draw them using the tail-to-tip method. Vector subtraction is the opposite vector addition, but the method is not all that different. If you consider what subtraction, another way in which you can write subtraction, okay? So if I had two vectors, A, which is this, and B, which is that, we're going to try to find A minus B. And what you can do is realize that A minus B for vectors is the same as A plus negative B. A plus negative B. So negative B, if we remember from our thing on scalar multiplication, the negative of a vector is just a vector, but its sign is switched. So its direction is switched. I apologize. So the direction is flipped. So that's the negative of a vector. So if we were to perform the vector addition, but instead with the negative of a vector, so let's just draw what the negative vector looks like. Same magnitude, but different direction. All right? So if we were to add A plus negative B, what we would do is take this vector A, then drag and drop negative B over here, negative B, such that the tail of negative B lies on the tip of A, okay? Then we draw the resultant vector from the tail of A to the tip of negative B. This resultant vector, this result, is equal to A plus negative B, which is equal to A minus B. So to subtract vectors geometrically, you would flip the direction of the second vector, B, and you would use the flipped vector and just perform a vector addition on it using the tail-to-tip method. Now, let's see what happens if we did B minus A. B minus A. So for B minus A, what we're going to have to do is flip the direction of A. So let's say with B, now this will be here, right? This is negative A. So we're going to do negative A. I'm trying to be very accurate. All right, so this is negative A. This is B. So the vector addition of B and negative A will be this. Like that. So what you can do is realize that the vectors of B minus A and A minus B, the directions are flipped, okay? So this top vector, A minus B, is facing kind of to the northeast, but this one is facing to the southwest, okay? So you can see that the directions are flipped, but if the directions are flipped, then one vector has to be the negative of another. So we can say that A minus B is not equal to B minus A because the directions are different, but A minus B is equal to the negative of the vector obtained from doing B minus A. Okay? So just a negative, and you can see the directions are clearly flipped. Also, just in vector addition, you can see that the magnitude of A minus the magnitude of B does not particularly equal the magnitude of A minus B. In this case, you could clearly see it in the top. In this case, you can clearly see it. Vector A minus vector B should be clearly smaller, but A minus B is clearly longer than either of them. So this is also true. The vectors, the magnitude of the vectors when subtracted does not necessarily equal the magnitude of the vector difference. Okay, so those are the basic vector vector operations. When we get to multiplying two vectors, things start to get a bit different. We'll see that next video. Thanks for watching and see you next time.